We take a look at 9.2. We're going to talk about central angles and inscribed angles. They're two special types of angles that we use when dealing with circles. And a central angle is just an angle whose vertex is at the center of the circle. Okay? What's really important about central angles is that its measurement is equal to its intersected arc. And an intersected arc is just the arc that's in between the mouth of the angle. Okay? So we look at this diagram. This angle right here, angle ACB, that's my central angle. The vertex is in the middle. It's on the center of the circle. Okay? The intersected arc is the arc that I like to think kind of the mouth of the circle. You start at one end, go through the circle, go to the other end. That's the intersected arc. So arc AB. And we know the central angle and the arc have the same measurement. So if the arc's 73, the angle is going to be 73. And vice versa, the angle 73, the arc's going to be 73. Questions over that? Another type of angle we deal with circles is called an inscribed angle. And an inscribed angle is an angle that has its vertex on the edge of the circle. So a central angle is angles in the center, inscribed angles on the vertexes on the edge. Okay? And it's important to know the measurement of the angle is half the intersected arc. Okay? Go back. Central angles are the same. Inscribed angles are, right? We sometimes get those two mixed up. So it's important to know. So here our inscribed angle is angle ACB because its vertex is on the edge of the circle. And its intersected arc, that is the arc in between. We go from A to B, that's its intersected arc. And if you notice, the arc measures 146. Divide that by 2, cut it in half, and that gives you the angle measure, 76. Okay? One important thing to know, because sometimes you're going to be given the angle measure and you're asked to find the arc. Okay? So when you're going from angle to arc, when you're going in reverse, do the opposite. So instead of dividing by 2, you're going to multiply by 2. So arc to angle divide, angle to arc multiply. Do the opposite. Questions over that? If we take a look at these examples, we're going to identify whether a given angle is a central angle or an inscribed angle, and use that to find the value of x. Okay? So we take a look at A. It's giving me angle ABC. Angle right there. Is that a central angle or an inscribed angle? Central. Vertex is on the center. It's a central angle. Okay? Well, x is that angle, so whenever my angle is missing, that's what I'm trying to find. I go to the intersected arc. The arc in between that angle. And what do we know about the central angle and the arc? They are what? The same. So if that arc is 35, what's that angle going to be? 35. If we take a look at B, this would be B right here. We have angle ABC. Is that a central angle or an inscribed angle? What? Good, inscribed. The vertex is on the edge. Okay, so now we have to find the value of x. Well, I notice x is my angle. So whenever my angle is missing, you go to the arc. And the arc measure is 44. Well, what do we know about the arc measure and the angle if it's inscribed? It's what? Not it. It's half. So it's half of 44. 22. So just divide that arc in half. It will give you the angle when it's inscribed. 22. We take a look at C. And what's angle LKJ? Well, what type of angle is LKJ, Haley? Where's the vertex? On the center or the edge? The edge. So it would be inscribed. Good. This guy. Right. And we have to find X. So I notice X is on the arc that's in between that angle. So whenever my arc's missing, I go to the angle that's intercepting it, which is 96. Okay, but I know it's an inscribed angle, so what I have to do is the angle to find the arc. Hyla, can you second it? Your phone's right, you're quiet. And you're correct. Mama? Multiply it by 2. Okay? So whenever you're given the inscribed angle and you're trying to find the arc, do the opposite. You're going to double it. We're going to multiply it by 2. And what's 96 times 2? 100. So X is 192 degrees. Arc to inscribed angle, divide by 2. Inscribed angle to arc, multiply by 2. Because if you notice, it's this arc is much bigger than that angle. It's getting bigger. Here it's getting smaller. So divide. And then we take a look at D. We have to classify angle GHI. Is that a central angle or inscribed angle, Bobby? So very good. Vertex is on the center. So if it's a central angle and I'm trying to find X, which is the intercepted arc, what do we know about X? What's its measure? The angle's 139, the arc's also going to be 139. We can take this concept and combine it to a good problem. Okay? So we take a look at A. We want to find the value of a missing variable. So we're going to find the value of X. And if I look, X is inside this angle. Okay. What kind of angle is that green angle? Central or is it inscribed? Central. On the center. Right? Whenever your angle is missing, you always want to go to the arc that's in between it. This arc right here. Did they give us that arc measure? No, they didn't give us any information on it. Okay? So when this happens, we have to use the other information in that diagram to help us find that arc measure so that we can find our angle. Okay? Like this is where the puzzle piece comes in. Well, I notice this red angle right here is intercepting that same arc. What kind of angle is that red angle? What is it? Inscribed, because it's on the edge. Well, what do we know about inscribed angles and arcs? What do we have to do with that angle? We're going to do with 41 to find the measure of that arc. What did we do on this one when we went from angle to arc and it was inscribed? Did we divide by 2 or did we multiply by 2? Multiply by 2. So same thing here. We're going from angle to arc. We're going to multiply by 2. What's 41 times 2? 82. So I know the measure of this arc is 82. Well, now that we know the measure of that arc is 82, what does the angle have to be? Alex? 82. Central angles and the arcs are the same. Done. Okay. Same kind of concept with B. Here's our angle. Okay. Well, whenever my angle is missing, I look at my arc in between, and there's nothing. It didn't give me that arc measure. So I have to use the other information in that diagram to find the arc. Well, I notice the central angle is inscribing that same arc. So now what do we know about that arc measure? That central angle is 62. What's that arc going to be? 162. They're the same. So if I know this is 162, what can I do with this arc measure now to find that green angle? Divide by 2 because it's an inscribed angle. And 162 divided by 2 is what? We get only 162 divided by 2. Let's see what you get. So I now know that x is 81 degrees. When this happens, there's a shortcut. Whenever you have an inscribed angle and a central angle intercepting the same arc, right? So it's kind of you have a central angle inside an inscribed angle. Okay, there's a shortcut. What did you notice here? When our inscribed angle was 41, what did our central angle be? 82. What did we have to do to 41 to get 82? Multiply by 2. We doubled it. So that's something you can use as a shortcut. Whenever you have this inscribed angle here, say this inscribed angle is x, we can just double x, and that will give us the measure of that central angle. You just take whatever the inscribed angle is and double it. You multiply it by 2, and that will give you your central angle. So again, shortcut. Central angle and inscribed angle are intercepting the same arc. Double the inscribed angle, and it will give you your central angle. Okay? And you can do this in reverse. You're given the central angle, instead of multiplying by 2, divide by 2, and it will give you the inscribed angle. Okay, that's kind of an important concept to know. You're going to see that a lot. Any questions over there? For example, see, it says find the measure of each arc. So this is kind of where that, kind of like figuring out a puzzle. Okay? For A, we want to find the measure of arc BD. That entire arc right there, that blue arc. How can we find the measure of BD? Does anyone find the measure of BD? Yeah, it's 90. How did you get 90? How did you, but can you add an angle and an arc together? Perfect. Here, this angle right here is the central angle. It's 32. So we know this arc BC is also 32. Now that we know what that little arc is, we just add these two together. 32 plus 58 is 90. We take a look at B. It's asking for arc ABC. This purple arc right here, ABC. Well, what kind of arc is that purple arc? Like, that's a semicircle. It's half a circle. What do we know about semicircles? What do they always equal? 180. So we automatically know that's 180 degrees. If it's going from one end of the diameter to the other. So how? The only how I would think of it is you highlight it ABC, and then I notice A is one end of my diameter, and it's going to C, which is my other end of my diameter. So I know it's making up half of a circle. Okay. For C, we want to find arc AB, which is this yellow arc right. Yellow arc. How can we find the measurement of that yellow arc? What do we do? Perfect. Subtract 32 from 180. 180 minus 32. What is 180 minus 32?
48.
Because if we know that whole purple arc was a semicircle, which is 180, we take away 32, we take away BC, we have that yellow arc. So 180 minus 32. 148. And then lastly, we want to find arc DAB. AB, that orange arc right here. How can we find the measurement of that orange arc? What is the measurement?
It's 270.
Perfect. 360 minus 90, it gives us 270. Right? Because we said early on, this whole blue arc was 90 degrees. And we know a full circle is 360. 360 minus 90 is a 270 degrees. Questions over that? Again, some of you may be sitting there, well, I did it a different way and I still got 270. You're right. There's so many different ways to go about getting the correct answer. Okay? That's what I love about circles. It's just how your brain sees the picture and how it processes the picture to get the right answer. Okay? We look at example 4. There's probably 5 or more ways of getting the right answers in example 4. Okay? You guys are working ahead and what you did is totally different from what we did and you're getting the right answer. That's totally fine. There's so many different ways to solve these problems dealing with circles. Okay? It's how your brain works. Okay? There's no wrong way unless you're just getting the wrong answer. So if we take a look here, it's saying arc BC is 34 degrees. Use that information to find the missing angles. We want to find the measure of angle 1, the measure of angle 2, and the measure of angle 3. Well, what's one of those right off the bat that we can find very easily? There's probably 2 off the bat we can find very easily. Yeah, what's the measure of angle 3? 34. What kind of angle is angle 3? It's a central angle. Here's angle 3. It's a central angle. It's the same as the arc. The arc's 34, angle's 34. Now Michael said measure of angle 1 is really easy to find. So I highlight it. What type of angle is angle 1? It's on the edge. We would call it what? Inscribed. What do we know about inscribed angles in the arc? What do we have to do with 34 to get the measurement of that angle? Wait. Divide by 2. What's 34 divided by 2? 17. So we know the measure of angle 1 is 17. The measure of angle 2 is going to take a little bit of work to get it. Okay, and again, there are so many ways of figuring out the measure of angle 2. Does anyone know what the measure of angle 2 is? Josh? 17. How'd you get it? It's a good guess. There's very specific reasons. You're right. It's 17. We know that. Anyone else have a reason why it's 17? Anyone else did some math and figured out how to make 17? Okay. Well, this is how I looked at it. In order to figure out, and I'm going to erase pretend like we don't know it's 17. Okay. What kind of shape do we have? What kind of shape is angle 1 and angle 2 inside? What's this blue shape right there? Triangle. What do we know about all the angles of a triangle? We add up to 180. Okay, well, if we can figure out what this middle angle right here is, that will help us figure out what angle 2 is. And there's multiple different ways to figure out what that middle angle is. One way is to see, oh, I have a semicircle. Okay, and I know this middle angle is the central angle. So if I can find its intercepted arc, I know the measure of that central angle. What is the measure of this intercepted arc? If this is a semicircle, and part of it's 34, what does this green piece have to be? 146. You just do 180 minus 34, and it will give you this angle, or this arc. So if this arc's 146, what's this angle going to be? 146, it's central angle. Well, we know all the angles of a triangle add up to 180, so we just do 180 minus 17 minus 146, and what does that give us? 17. Okay. You could have also said, oh, this arc is 34, I know this central angle is 34. And these two angles next to each other make a linear pair. Well, linear pair angles add to 180. 180 minus 34 gives you 146. Do the same math. So get the right answer. Different way of looking at it. You also could have done this. I notice here, I'm going to do some erasing. What type of triangle is this triangle? Special type. What do you notice about these two sides? They're both what? What's AM and MB? What part of the circle are they? What's going from the center to the edge? The radius, right? And we know the radius of the same circle, so they're the same. So now, what type of triangle is that? Two sides are the same, we call it isosceles. Well, if we have an isosceles triangle, what do we know about these base angles? They're what? The same. Well, if we knew this was 17, we don't even need to know what this angle is. What does that angle have to be? 17. And there's another way I can show you, but I don't want to give you blow your minds. Okay? You could have done, this is an exterior angle of a triangle, and we know the exterior angle adds to the two remote interior, so you could have done 34 minus 17. Okay, there's like 5 or 6 ways of getting this problem correct. It's just how your brain looks at it and solves it. Okay? There's really no wrong way unless you're just not doing one of these correct. Questions over there? Okay, go ahead, you got some time.